Hi, my name is Henry Zai.
My name is Rain Bolavino,
I'm Galen Dia.
and today we're going to show you our ME106 project, which is called the Chargeable Solar Tracking Device.
The purpose of this project is to address the problem of solar panels. Currently, most solar panels are either stationary or they only have one axis of freedom, which make them inefficient.
So, what us as a team wanted to do for our solution is that we wanted to make a solar panel that could have 2 degrees of axis freedom. So it could go with anywhere over the sun's location, anywhere in the sky. And also as a result from that, it would store the solar energy that we'll get from the solar panel and turn it into electrical energy, and as a result put it to the battery for other uses such as like mobile charging and whatnot.
Now we're going to demonstrate how this system works and show you each component of the system.
So the way our solar tracker works is by taking in the sunlight from through the. So the way our project works is by taking in sunlight through each cell and then comparing them. As you can see, we have 4 cells in the 2x2 grid. So if we point light at the right cell, it turns to the right. So that way the left cell could attempt to get more light. And if we point at the left cells, it turns to the left. So that way it compensates, try to equalize the left and right directions. Also, if we do it to the top or bottom, it either looks up or down. So whichever cell has more light on it, it will go towards that direction to try to make each cell equal in the comparator. The next thing it does is it sends the voltages into this circuit. Alright, what this circuit does is it combines all the voltages in series and parallel to get a total of up to 11 volts and 0.6 amps. Through that, it goes through the circuit and it's controlled by the Arduino in PWM. So when the battery is charged, is undercharged, it sends a PWM signal of 100%, so that way it's constantly charging. But as soon as it gets to up to around 99% or 97%, this PWM signal slows down to about maybe 5%. So that way it prevents the battery from overcharging or undercharging. This circuit also controls whether the battery outputs to a load or not. We have an output to load here, and we generally don't want loads to be connected to the battery itself, because that would allow the battery to completely unload or undercharge. And to monitor voltages, we use this LCD screen. So on the first page, we see cell voltages. These are the voltage readings from each cell that are not compensated to compare. This is the charging voltages. On the top we see the averages of each cell combined in series and parallel, which totals to currently about 5.1 volts. And from the battery we see 8.2 volts. So currently the solar cells are giving off a voltage less than what we have on the battery, so it won't charge. And then if we go to the last page, we can see that it's not charging in the battery level that it's at right now.